Hey everybody, it's Michael. Welcome back to Let's Explore Unity. This is episode 9, and I said that we would take a look at prefabs a little bit more, but actually a comment on the last video from Dao Su says, quote, I've learned about arrays and loops before, but they've never been explained very clearly. Maybe you could make an addendum video. And actually that's a really good idea because this second spawn video was going to actually deal with a little bit more complicated side of that. So why don't we take a look at arrays? And if you're a longtime programmer, you probably already know this stuff, so you can go ahead and skip ahead. Although I am going to show some examples and how they can be used in Unity a little later on. So let's talk about arrays. What is an array? An array is, we've learned about just having a data type, right, that holds one piece of data. So an integer called boy that holds the value 1, right? But you can't do a whole lot with that if you start talking about needing to, I don't know, represent a chessboard, for instance, right? And that is where arrays come in. Arrays are basically a fixed collection of values of a given data type. And there's kind of a lot of variety here. So let's take a look at them. And we'll start with the simplest kind, which is called a 1D or one-dimensional array. So you can think about this like, I don't know, a compartment, a drawer, or something. And depending on whatever type you want it to be, this can be representing a group of integers or floating point values or strings or any other data type that you want it to represent. And you say, okay, look, I want an array of this big, right? So I want it to be 10 units big. That means you're going to get 10 drawers to put your stuff in. So let's say I make an array of integers that's 10 big. I can put in 10 different integers into that array. And they're going to be sorted by the order in which I put them in. And that's called the indexing. So each of these boxes or compartments has an index number. And in the case of a 1D array, we've just got a line of these guys. The first one is 0. Array numbering always starts from 0, and that can really trip you up. So keep that in mind. It starts at 0, 1, 2, 3, 4, etc., all the way until we get to the size of the array minus 1. The reason I say size of the array minus 1 is because we start with 0. So if we had 10 places, it would go 0 through 9 as opposed to 1 through 10. The size minus 1 is an important thing to keep in your brain. So this is a one-dimensional array. How could it be useful? Well, you could put a deck of cards in it. That's not the way I would do it, but you could do. And you could, for instance, just put a list of things. Like, let's say we had a bunch of tiles representing our world for our tile map, right? We could use this. We could have an array of images where each of these little cells holds a different tile and use it that way. And we'll look at that in just a minute in Unity. But let's look at something a little more useful. Well, not more useful, but more commonly used, I guess, for representing data in games. A 2D array, which is, as you might expect, just a two-dimensional version of the one-dimensional array. Along here, whatever we choose to call this axis, we've got cells labeled 0, 1, 2, 3, 4, all the way up to size minus 1. And over here, we've also got a second coordinate. So 0, 1, 2, all the way up to size minus 1 in this axis. So this cell here is 0, 0. This cell here is 1, 0. This cell here is 0, 1. So that is a two-dimensional array, and it can just hold, however many. If you've got a 10 by 10 two-dimensional array, it's going to hold 100 of whatever data type you've declared. Integers or strings or whatever. So that's a two-dimensional array, but it doesn't stop there. You can go three-dimensional, and so here's where we start getting more axes. So this cell over here might be 0, 0, x and y, but it also might be 0 in the z-axis. So basically we've got a big, I don't know, it's a giant IKEA shelf that we can put lots of things into. And beyond that, we've got n-dimensional arrays, which I can't really show you graphically because I don't happen to be Carl Sagan, but you could easily have a 4, 5, 6-dimensional array if you can figure out a way that in some reasonable way, simulates the data that you're trying to represent here. I mean, we can all think of reasons to have a three-dimensional array, right? Why do you need a four-dimensional array? I'm not entirely sure. Maybe you've got a reason. I don't believe I have ever used one. I might have. So let's look at how this works in code. So an array has a declaration. We have to declare it and say, look, we want an array. And we have to instantiate it, which means we have to sort of make it real in the game. We're going to say this thing is an array, and we're going to give it a size and all of that. And then we have assignment, where we tell the array what its values should be. So let's look at this. The generic form of it is the accessibility modifier, so public, private, protected, etc. Or you can leave that off, and it'll just be assumed to be private probably. We tell it what type, and then we give it some brackets. These little brackets here are kind of the signature of an array. And then a name. Every variable needs a name. So the example I've given here is we have a public array of integers called numbers. So that's how we would declare this. Now, notice we haven't told it how big this array is yet. We do that in the instantiation process. So that is simply, we tell it the name of the array equals a new, to allocate memory for it, array of this type of variable of a given size. So our example, numbers equals new integer array that is 10 long. This is a one-dimensional array. We'll talk about higher order dimensional arrays a little bit later on. And then to assign a value to, for instance, a given cell in that array, we would use the name of our array, use brackets, and put an index number inside, and then give it a value. So, for instance, numbers at index 0 is equal to 15. So that's the basics of using these things. Now, when we want to do more, we can look at the idea that, well, we don't have to do all those in separate steps. We can do it all at once. We can declare the array. So I've left off the accessibility modifier, but this could say public integer with the square brackets, noting that it's an array, called numbers, is equal to a new integer array of size 5. And then we can actually go ahead and give it values for those 5 entries. 1 to 5 in this case, but you can put whatever you wanted to in here. This is not all that common. Usually these things are going to get assigned in code, but if you know ahead of time that you need an array that's 5 long that has 1, 2, 3, 4, and 5 in it, well, go ahead and do that. So that is how you can tie it all together, though. And then we have multi-dimensional arrays. So let's talk about how those are done. It's easy enough. All you got to do is put a comma in here. So it's a little abstract looking, but if you think about these little brackets as being your array, and we've got a comma in there, there's something on the left of the comma, something on the right of the comma. There's two indices into this array as opposed to just one up here. So it's a two-dimensional array. So it works exactly the same. Otherwise, when it comes time to address the array, to pick a specific cell, we give it 2 values. So here we're saying that index number 3, 2 is equal to 7. And then the same thing for a 3D array. We just use 2 commas, 3 items, and we can address it by giving it 3 different numbers. Now, significantly, these indices always need to be an integer. So if you're trying to convert some other thing, like you can't use 2.0 here, right? That doesn't work. You have to make it into an integer, which you can do in Unity or just C#. And I think that really is it. So let's look at some practical applications for this over here in Unity. I've just got I've just put a quad into the world. This is the origin over here, probably where our light is. I don't know if I can get that. Yeah, here it is right here. This is our origin right over here. And this is just a quad that's laying on the ground. I've made a few little prefabs, just a cube, a cylinder, and a sphere that are slightly less than 1. And let's go look at how we might be able to use this thing. So I've got a script here. It's just called arrays. There's nothing in it right now. I'm going to drag it onto a game object in the scene, which is called managers. Doesn't matter what it's called. We just want to get it into the scene. I'm going to open up MonoDevelop and get rid of that thing. And we're going to make the font a little bit bigger. Okay, so what can we do with these arrays? Well, for one thing, we can use them as a way to get stuff in the inspector. So if I declare a public Let's see. I'm just going to grab these game objects. So I'm going to make a public game object array. So I do that by putting little brackets there. And let's call it our prefabs. So if I save this and we go back over to Unity and take a look at our script on the inspector, you're going to see that now we have a little drop down arrow that says prefabs. We can click that and we'll see size is equal to 0. I could type in a size here and it's going to give me 4 slots, but let's just leave it alone. Let's not put a size on it. Let's just put 0 back in. Our slots go away. But when I grab something that matches the type it's looking for and drag it over here to this little thing, it'll drop it on and it'll increase the size for me automatically. So I could put any number of these things onto here. And I could also do, if I put 0 back in here again, it'll clear that array. I could just go ahead and grab all of these as a group. Notice I lost my manager though. So let's click the lock button so that stays locked. I think that's locked. I can't really see. It is, yeah. So I can just grab shift, select all of these things and drag them over to prefabs and they'll go in. They'll go in whatever order they were down here, probably alphabetical. So that may not be what you want. If you want these in a specific slot, you'll have to assign them one by one. So now inside of our code here, this game object prefabs holds those prefabs, and there are 3 slots in it. If we wanted to, what we could do, let's see, debug.log, and let's just output the array size. I'm just going to shortcut that by saying size. So we can get the size of an array, how big it is, by using the name of the array and the member variable length. And I'm going to put that to a string. I may not need to. I'm not sure. I'm never sure whether I need to do it or not, but you can always do it. So we're going to be getting an integer that specifies the length of our array. And if I'm not mistaken, that integer is going to say 3. So let's save this and go back over here. Let it compile. We'll open up our console and play. We should, yeah, size 3 right there. So there we go. We can now deal with our array inside of our system over here. If I wanted to, I could say instantiate and pass it one of these prefabs. So I could say prefab number 0, index 0. But let's just instantiate that and see what we get. So I'm saving it, going back over here, and let's press play. And sure enough, there is a blue cube at the origin, because cube is element 0. If we had put in 1, we would get a cylinder. If we had put in a 2, we would get a sphere. So that's pretty cool. But let's see how we can, let me unlock this guy here, I'll forget. Let's go back over here and figure out what else we can do with arrays. Well, one thing we can do, we can also represent things in the game world. We could just represent a chessboard, for instance. We could have an array, an 8x8 array of integers, with each integer in those cells representing a number of a chess piece. You know, 1 for a pawn, a 2 for a rook, etc. Or we could, for instance, use it to represent game objects. So let's just make a one-dimensional array. I'm not going to make this public. I'm going to make a game object array of just one dimension, and let's call it objects, maybe. Is it like, yeah, objects is fine. And on start, let's do a little loop here. So, well, first of all, we have to instantiate this array. So we're going to say objects is equal to a new array of game objects. Now see, it already knows what I've declared objects as, so it's giving me this option here in the suggested text. It's going to automatically set that up for me. So now I've created a new array of game objects. What don't you like? Oh, I see. Must have array size, right. I'm missing a key piece. We need to tell it how big we want this thing to be. Let's make it 5, let's make it 10 big. Okay? So this is created an array of game objects of size 10, and they can be indexed using the numbers 0 to 9. Remember, again, it starts at 0 and it goes to the size minus 1. Okay, so let's make a little for next loop. And this is another thing that Dalsu asked about is loops. A for next loop, and by the way, all I've done here is used MonoDevelop's little insta-type thing. So if I type for and then hit tab twice, I get a little fill-in. And then I can just kind of automatically go through here and make stuff happen. So the first thing is going to be I, which is our counting variable. And the second bit is going to be our size, how high we're going to go. So what we're going to do is say objects.length. You got to type the whole thing. And let me get out of that so we can actually read it. So what we're saying here is start out with x being equal to 0. And while x is less than objects.length, which is the length of our array, which is 10, we're going to increment this variable every time through the loop. So we're going to start out at 0, we're going to go to 1, we're going to go to 2, all the way up to 9. We're not going to get to 10 though. X is less than objects.length. That's only going to get us to 9, so we're not going to exceed the bounds of our array here. And by the way, if you try to use an index that's out of range, if I try to use -1 or 10, for instance, as an index to this, I will get an error from Unity because the array isn't that big. So what are we going to do inside of this loop? Well, why don't we just instantiate one of these objects? But let's get a little bit fancier. I'm not even going to keep handles to these because we're just instantiating them. They're going to be in the world, and they'll get cleaned up later on. We don't have to deal with it. So we're telling it what prefab to give us, but we're giving it a 0. So why don't we have it give us a random prefab instead? So I'm going to use random.range, which is going to give us an integer between 0 and, this is actually giving us a, okay, it's giving us a float. That's fine. We can cast it to an integer. I'm confused. Hang on. Yeah, I'm just being a derp. There are two versions of this, and I'm not sure how. Sometimes it shows me the float, sometimes it shows me the integer one. Well, anyway, we're going to have it give us an integer between 0 and objects. Actually, not objects. We want it to be our prefabs. Prefabs.length. Now, how is this going to work? Well, let's take a look at what random range says. It says it returns us a random integer number between the minimum number, which we're giving it 0, and it says inclusive in brackets after that, and max. And it says, notice that it says exclusive. It means it doesn't include. It won't ever return us one as big as the max number. It'll return us one up to. So our prefab's length is 3. It'll give us a random number between 0 up to 3, but it'll be an integer. So it'll give us 0, 1, or 2, which is exactly what we got. We've got 3 prefabs. This is going to give us a random one. And then let's make it be at a position. So we're going to give this guy, nope, I've done that in the wrong place. So put rid of that comma, put a comma here. So now we can give it a position to spawn at. And so we're going to do a new vector 3. And where will we put it? Well, let's just put it in world space in relation to its index value, right? So x is our index value. Let's just put it right there. So we'll give it an x value equal to x, and we'll just put it at 0 and 0. Actually, I will put it at 0.5 in the y because where the cube is actually its center is at 0. So let's do it that way. And then it also wants a, it's also going to want a rotation since we're using this particular version of the instantiate method. So we're just going to give it quaternion.identity, which will just give us no rotation at all. And that will be fine, I believe. So we're going to loop over our array, going from 0 to 1 minus the length, basically. And then we're going to instantiate an object at that location, at our x, one of our random prefabs from this array up here. So let's save this and try it out. Okay, I'm going to run it. Oh, all compiler errors have to be fixed. Let's see what it wants. Unity Engine Vector 3, float, float, float. Oh. Because I didn't use an F right there, and it thinks I'm trying to give it a double when I'm really trying to give it a float. those should go away. Yeah, they do. All right, let's run it. And yeah, we get a little line of things that should be 10 long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 items chosen randomly from our prefabs array. Let's quickly look at how we can extend this to other dimensions. So if we were to instead put a comma inside of this little guy here, we're going to be declaring this as a 2-dimensional array instead of a 1-dimensional array. And then here in our instantiation, we can give it another dimension. So we're going to say it's 10 by 10. And in here, instead of just having a for loop counting the x, let's also make a for loop. And let's count y. So from y equals 0 to y less than objects.length. I picked the wrong thing to call it, objects, because there is an object thing in C#, so it's getting confused. Come on. All right. So here's what we're doing. We're counting in x. For every x, we're also going to count in y. And so we're still going to get our random prefab, but now instead of giving it a... Well, okay. I'm going to be putting this into the z world space coordinate, just because I think backwards from Unity. So at x and y, z, I know that's a little confusing, but basically we're going to be assigning these things in 2 dimensions. Let's take a look at it. My words are failing me here. But what we're going to get is that. Oh, gosh. Yeah, it became very large, didn't it? How did it become very large like that? Well, honestly, I don't know. We're only counting up into objects.length. Oh my goodness, it gave us the entire thing. So it gave us 100. We actually don't want to use that when we go 2-dimensional. My mistake. I apologize for that. I'm just going to hand put in 9. What you would probably want to do, in fact, why don't we just do this? I will just say integer and grid size. And then here, I'm just going to say that the grid size is equal to 10. And then I'm going to grab that grid size and put it into here. So now we have grid size there, and I can put grid size -1, or actually we don't need to if we're using less than, that's fine. There's our grid size there, and we should be good with this. Yeah. So when you use multi-dimensional variables, the length is going to be x dimension times y dimension times z dimension, etc. Remember that, because I didn't remember that. And there we go. Now we have a 10 by 10 array of random objects. Let's do one more thing. Let's try a 3-dimensional. So I'm just going to put another comma over here, and I'm going to put another comma grid size right there, and then I'm just going to duplicate this loop, and I'm going to change this z to a y. I'm sorry, change this y to a z. So now we have x, y, and z loops. So we're going to x will be 0, y will be 0, then z will be 0, and we'll go all the way until z is just 1 less than the grid size, and then we'll go to y equals 1, all the way, and keep repeating until we get fully done with x being at 9, and do all of that. So here we're just going to take z, and I'll add that 0.5 to it, so our bottommost one spawns on the grid. I'm going to save it, and let's run it. And now we get a 3-dimensional board cube made up of various little gadgets. And you know, those things, if we need to get access to them, we can easily do that. So let's take one more quick look. So I can destroy one of these. This is an array of game objects, right? So if I say destroy, if I type it right, If I type destroy and the name of an object, right? So what object we're going to give it? Well, let's give it objects and give it an index of 0, 0, 0. And that's going to destroy the game object that lives at 0, 0, 0 in our array. Let's take a look and see what happens with that. I believe we'll be able to see that. We should be on the right corner for it. Can we not? Yeah, we can't. I'm not exactly sure where our camera is in world space here. Let me pause this and see what our camera is looking at. You know, I'm using one of Unity's weird little cameras, so I'm not entirely sure. Let's just try destroying a different one. Let's try destroying the one at 10, 0, 0 and see if we can see that. I think we will be able to. Yeah, no, hang on. Something broke. Oh, because I did 10. See, I'm hitting all the high notes, the errors here for you. The biggest value that we can index in our array is 9, not 10. That should fix our error problem. But you see we get an index out of range exception. And that's left over from last time though, so we should be able to run it now. Well, where the heck is that piece? I don't even know which side we're looking at. Leave me pause, I'll find out which side we're looking at, and I'll delete one of them. Okay guys, well, long day at work or something, I guess. My brain is not working up to snuff here. Remember I said how we were just going to instantiate these and not assign them to anything, and it would just get cleaned up later? But yeah, that's fine until you want to go ahead and use them. So we did actually want to go ahead and use them, and I wasn't keeping any reference to them. So here's how we do that. We're going to just assign objects x, y, z to the results of this instantiate, which this is going to give us back a game object. We're going to store it in our array of game objects, and then we're going to do something with it. And what we'll do with it, I just figured I would do this way, is we'll just get input, get any key down, which means just any frame where we hit a key, we're going to get a true back out of that. And if that's the case, we'll check, just to double check, make sure that that location, 0, 0, 0, is not equal to null. In other words, that there is actually a game object there. And if there is, we'll destroy it. So let's save this and go back over here to our scene and press play. And there's our big board cube of stuff. Now watch this little blue cube right here. As soon as I press a key, it'll go away. So there you go. And we could do a similar thing. I mean, if we wanted to, we could go in and iterate through the array and make these things fly off in different directions, or do whatever we wanted to them. Change their material. We could respond to clicks on them, all kinds of stuff. So that's the basics of arrays. Next time we may look at lists, or we may go ahead and yeah, actually I think we will come back and look at lists, because lists are kind of a, these are great if you want a structured data source. So I want a 1, 2, 3, 4 higher dimensional array where everything is sort of fixed in place. But there are other things which are given to us by system.collections and system.collections generic. Lists, queues, dictionaries, and other types of data storage methods that give us a lot more flexibility than an array does. An array is perfect if you know how big you need the thing to be. You need stuff that comes and goes, or you need something that ties one piece of information to another piece of information. You want to start looking into things like lists and dictionaries and sort of things like that. So we'll take a look at those next time around. All right, I'll see you guys soon. Thanks a lot for joining me. Bye.